everyone, my name is Alika Widuri Kartika with the assistant code AKA. So I will explain module 2 about the data type and algorithm components, which contains various data types and their uses, the structure of the C language and the examples of their use. Okay, so in the first one, we'll talk about the structure of C language and the programming C language structure. This is the header. The ending in .h are files that contain function prototypes, constant definition, and variable definition. And then this is the hashtag include processor. It's a command used to set the compiler to read the header file. And then this is the main function. Inside the main function there are statements, and each statement in C is written with a semicolon ending. You can see at the example letter the use of semicolon in statement. And then this is the other function. The other functions are only used when you need it, so it depends what or how many functions you need to use or what a program you want to use or make. So it depends on you when you need it or not. So the second one, we will talk about the variables and constants. Variables and constants are names that state a place in computer memory and contain a value. The contents of the variable can be changed at any time when the program is executed, while constants cannot be changed when the program is executed. You need to take note that variables and constants are contain a value. If you use the variable in your program, you still can change the value at any time when the program is executed. But if you use constants, you cannot change the value when the program is executed. So that is the difference between the variables and constants. These are the examples of variable, and these are the examples of constant. As you can see in the examples of constant, they had a value in it and used a const in front of it. And the next one is things to consider in naming variables and constants, or the rules in naming variables and constants. The first one is name must begin with the letters of the alphabet from A to Z. With the capital or not, you can use all of the letters or used underscores. And the next one is following characters can be letters, digits, or underscore characters. Maximum length of an identifier is only 32 characters. If more than 32 characters, then the initial 32 characters are considered. And the fourth one is spaces are not permitted. The next arithmetic operators like plus, minus, divide are prohibited. And no special character, for example like a colon, semicolon, hashtag, or add, or and, are prohibited too. And the last one is C language is case sensitive. They are very sensitive, therefore capital letters and non-capital letters are distinguished. Okay, next, the third one, we'll talk about the data types. The first one is integer. Integer int is to express integers between this range. For example, like 0 or 1 or 9 or -1, -100 or -259. You can use the integer. And then the next one is float. Float is to express a real number between this range. Usually float is used to express a decimal number. And then the third one is char. Char is to express characters. And then the fourth one is boolean. Boolean is to express a logical value. Is it either true or false? So this is the data types and the format specifier. The first one is integer. You can use %d or %i. It's the same. And the next one is float. You can use the %f. Char is %c. String is %s. And double is %lf. And the other data type you can see at your module. For the other data type and the format specifier. And then format specifier writing patterns by default. The C language displays a decimal number with 6 decimal places. And the printf command has special rules to set the C language to display the number of decimal places. For the basic format is %f for using float. Description displays 6 digits behind the decimal point. So for example, it's like this. So basically, if you used only %f, it will display 6 digits behind this decimal point like this. There are 6 0 behind the decimal, and then the %.xf displays x digits behind the decimal point. For example, if you use %.2f, there are 2 digits behind the decimal point. And then the third one is %xd to displays x digits with spaces as separators. And then %0xd to display x digits with 0 as separators.
Good afternoon, I'm Ahmad Bati. Now we will learn about the operation of arithmetics using such data types. Only integer and float data types can be used. The following operators are available for arithmetic use. Multiply used to multiply number, divide used to divide numbers, addition or plus used to add three numbers, reduce or minus used to reduce two numbers. And then we have modulo or module or mod we usually call it, used to find the remainder of division from two numbers. The operator in C is percent. This operation can only be used by integer data type. Now we have struct. Struct is a data type that created by the user. This type is made because there is a relationship between variables which when combined have a common purpose, though each variables can differ in each of their type. For example, we have struct data with string of character name, ID, and major, but we need integer for the grades. And then we wrote students below as the name of such struct. To assign value to variables, we can just use the variable name equal to their value, or we can input it by the user by using scanf command. Or we can make a constant. That means the variable value will not ever change. That's it from me. Thank you. Good afternoon.
Hello everyone, my name is Gary Nelson with assistant code of SOH, and now I will continue on the video. So let's get into the examples. First, we have the use of constants. There's two ways of declaring a constant. First, using #define, and second, using the const keyword. So for the first example, we are going to use #define to define a constant. So see in this example, we are defining height as 175, and we are defining first letter as W, and we are defining full name as Will Smith. So when we print out with their appropriate specifier, as in height is defined as an integer, so we use %d or %i. Then first letter is defined as a character, so we use %c. Then full name is defined as a string, so we use %s. So when we run the code, it will print out correctly. Alternatively, we can use constant the constant keyword like in the second method. So let's enter it. See, when we change it into, when we use const, it will still run properly. So what's the advantage, or what's the difference between a constant and a variable? So a constant's value cannot be changed. So in this case, height will always be 175. The value of first letter will always be W, and the value of full name will always be Will Smith. Also, I also need to mention about these symbols, like this one and this one. So those are called comments. So what they essentially do is to give description to the code, and the compiler will not execute anything inside the comment and actually will skip it. So these are called multiple line comments. See, they expand between line 1 and 5 in this case, and these are called single line comment, and it will only affect in this line. So in this case it is only in line 7. So let's continue to the next example where we will be using constants in a simple calculator. So this program is a simple calculator to calculate the volume of a cylinder with a fixed height of 10 centimeters. So as you can see here, pi is defined as 3.14, and we are using the hashtag define. And another constant is height, which is 10. And we are using the const keyword for this constant. And we have the integer radius, and we have float for volume. So when the program is executed, first it asks for the radius using the correct format specifier. As seen here, radius is an integer, so we use %d. Then we compute the volume. Then it will print out the value of volume, and as we can see here, it's a %.2f format specifier, so it will only print out 2 digits behind the decimal point. So let's try to run the program. So let's say the radius is 7. Then it will output volume of cylinder is 1538.60 centimeter cube. So that's the example of using a constant in a simple program. So let's continue to our last example where we'll be using struct or structure. So in this example, we have a struct called biodata. Inside this struct, we have multiple data such as name, major, name, and class. And inside a struct, we can have multiple data types. Like for example, we can add integer grade. And at the end of this struct, we have this b and semicolon. So what's the function of this b? B will be used to refer to this struct. So for this example, we have b.name. So b is referring to the struct by data, and name, we are referring to this data. So when we run the program, it will first print out the name, and it will ask for the string of b.name, and continue. It will do the same for major, name, and class. So let's add a new example where we'll be also requesting for the student's grade. So grade \t. I also need to mention that the function of this \t is similar to when you press tab on your keyboard. So it will shift your cursor a couple spaces to the right. And also the function of this \n, it will create a new line below this line, like when you press enter on your keyboard. But it will only do it in the output. So okay, let's continue. And since we are not requesting a string, we will be using scanf. And we will be still using b.grade. And we will also do the same in here. Grade \t %. backslash n, comma, b dot grade. So okay, let's run the code. So I'll input my name, for example, maybe Gary, and then I major in electrical engineering, and maybe I'll put random numbers here. Let's say it's 97. Then it will output this. So maybe that concludes the use of struct, and that will conclude also this video. So thank you for watching and see you next time.